Ancient engineers built these monuments without stacking a single brick. To create these spaces, they had to move directly into the mountain, relying entirely on carving inward into solid stone. This is subtractive architecture. In traditional construction, you add material to build up. Here, you remove material to hollow out. This method is unforgiving, as every mistake is permanent. In the 6th century, the Chalukya dynasty transformed the sandstone cliffs of Badami, India, into a laboratory for this specific architectural method. Subtractive engineering leaves no room for error. A single miscalculated chisel strike can compromise the structural integrity of the entire site, and there is no way to replace the rock once it is gone. Selecting this site required a deep understanding of the raw material available in the Karnataka landscape. The red sandstone here possesses a rare combination of traits. It is soft enough to be sculpted with hand tools, yet strong enough to support incredible weight. The uncarved cliff face looming over the temple entrance exerts millions of tons of downward pressure on the hollowed-out voids below. Excavating into this weight is a gamble against geology. Natural fault lines or hidden fractures within the sandstone could cause the entire ceiling to collapse without warning. The Chalukyan architects moved forward by treating the local geology as their primary blueprint, ensuring every chamber was positioned to withstand the immense forces of the mountain. The excavation followed a strict linear path, starting at the cliff's outer edge and tunneling through the veranda into the central hall, finally reaching the inner sanctum. Engineers calculated exactly how much stone could be removed before the ceiling lost support. These massive pillars are the strategic remains of the living bedrock, intentionally bypassed to funnel millions of tons of pressure from the mountain above into the ground. Artisans shaped these columns into intricate geometric forms, while the stone was actively supporting the weight of the cliff. The architecture of Badami is defined by what the excavators chose to spare, the deliberate preservation of solid stone within the void. The Chalukyan architects merged several geographic traditions into a single building style. They developed the Visera style, which finds a mathematical balance between the northern Nagara and southern Dravida architectural techniques. Implementing this fusion within a subtractive environment meant the engineers could not rely on standard construction rules. They had to adapt every motif to the realities of solid rock. These deep relief wall carvings serve a structural purpose. By maintaining significant stone thickness behind the figures, builders ensured the walls could still support the ceiling. At Badami, the artistry and the engineering are inseparable. The religious iconography is part of the system that keeps the mountain from collapsing. While the individual caves show micro-scale precision, the entire site was planned as a large-scale infrastructure project. The site features environmental engineering designed to manage water flow across the terrain and integrate the caves into the local water table. The cliff excavations maintain a direct spatial relationship with the Agastya Lake below, which dominates the valley floor. The Chalukyas treated the entire landscape, cliff, water, and stone, as a single interconnected system. The final layer of their planning involved engineering these stone voids to interact with the sun. At the base of the Panchalinganafati boulder is a small, dark opening known as the empty cave. This cavity was carved with a specific solar alignment, allowing the rays of the rising sun to penetrate the back of the cave every day of the year. Freestanding structural temples often align with the sun only during the solstices or equinoxes. Achieving this daily connection within a carved rock cavity required a much higher degree of spatial calculation. Lighting simulations prove the cave's dimensions were calculated to catch light even during the sun's most extreme northerly and southerly risings. The result is a precise interaction between light and stone, with the sun's rays piercing the entrance and reaching deep into the sanctum. This engineering likely supported regional beliefs. Folklore suggests the light was intended to pay homage to the sun god, as a healer for the king Kostraya. 14 centuries later, these carved voids still track the sun and support the mountain, preserving the exact geometry calculated by their 6th century architects.